Shop designs a new gear system for their bikes. They use a 4-inch gear for bikes with a 22-inch wheel diameter. If the ratio of the gear to wheel diameter remains constant, what is the size of the gear for a bike with a 26-inch wheel? Okay, so we want to set this up as a proportion. So we've got a 4-inch wheel, or a 4-inch W. No, I'm sorry, 4-inch gear. My bad. A 4-inch, well, they're both inches. So I'll just put 4-inch gear for a 22-inch wheel. So 22-inch wheel. And now we want to know we eventually want to know for a 26-inch wheel. So we want to know for a 26-inch wheel. I've got my gears on top. I've got my gears on top here. My wheels down here. We got to have my wheels down here. Okay, now one thing we could do to start off is we could simplify this. This 4 and 22 can both be divided by 2. 4 divided by 2 is 2. 22 divided by 2 is 11. So this is the same as a 2-inch gear would have an 11-inch wheel. Okay, now if this was 33 or 44, we could just do times 3 times 3 or times 4 times 4, but it's not. It's 26. So something times 11 does equal 26. Well, how do we figure that out? 26 divided by 11 will tell us what times 11 gives us 26. So 26 divided by 11, we can leave it like that. 26 over 11 times 11 gives us 26. So 2 times 26 over 11, make 2 over 1, will give us 52 over 11. So 52 over 11 would go up here. Now we can make this into a mixed number. That's the same thing as 44 over 11 plus 8 over 11. And 44 over 11 is just 44 divided by 11. That's just 4. So we have 4 and 8 elevenths. Okay, now we also could have done this with a calculator. Remember, we were looking for this missing number right here. We were looking for the size of the gear for a 26-inch wheel. We also could have cross multiplied and divided. We could have said 26 times 4 divided by 22. This times this equals this times this. So if we multiplied those two together, but if we did that, we would get a decimal instead of a mixed number, but we still would have gotten the same answer. So we could have done 26 times 4 gives us that, and then we divide by the other number, divided by 22, and we get 4.72 repeating, which is the same thing as 8 elevenths. 8 elevenths is also 0.72 repeating. So you can say 4 and 8 elevenths, or you can say 4.72 with a hat on both the 7 and the 2, because both of those are repeating. We also could have gotten a scale factor. Said what times 22 equals 26? Well, 26 divided by 22 equals that. That's our scale factor. So then we do that times 4. So if that 22 times 1.18 repeating gives us 26, then 4 times 1.18 repeating will give us this number, and you'll see, there we go, 4 and 8 elevenths, or 4.72 repeating. Okay, number 2. 75% of the girls in Mrs. Thompson's class own a smartphone, compared with 62.5% of the boys. If there are 20 girls and 8 boys in Mrs. Thompson's class, how many students own a smartphone? Okay, so let's see. 75% of girls. So 75% of 20. Well, 75%, as you probably know, is the same thing as 3/4. 3/4 of the girls. Well, how many girls are there? There are 20 girls. If 3 out of 4 girls own a smartphone, then how many out of 20? Well, we just do times 5 times 5. That's got to be 15 girls own a smartphone out of the total of 20. 75% of 15. We also could have done 0.75. 75% of 20 is 15. It's 0.75 times 20 also would have gotten us to 15, finding 75% of 20. So we got 15 girls own a smartphone. How many students? So we got to find out how many boys. Well, there's 8 boys and 62.5% of them own a smartphone. So we could turn this into a decimal, 0.625, and do that times 8. And that would give us our answer. But you probably know 62.5% is just 5/8. 5/8 is 62.5%. So 5 out of 8. 5 boys out of 8. This also would have given us 5. But if you can recognize this percent is a very common percent, 5/8 is, so 5 out of 8. So how many students? Well, we have 15 girls plus the 5 boys. We've got 20 students own a smartphone. 20 students out of the 28 total students have a smartphone. Okay, so rounded to the nearest percent. What percent of the students in Mrs. Thompson's class own a smartphone? Okay, well, we just got to do, having some difficulty here. So we got 20 out of 28. Now we could just top in, bottom out, but first let's simplify this. Divide by 2, we get 10 out of 14. Oh, we can simplify this again, right? We could say 5 out of 7. 5 out of 7. Well, what percent is that? 5 goes in, 7 goes out. Tebow, top in, bottom out. 5 becomes 5.000, so we can round to the nearest percent. So 7 goes into 5 0 times. 7 goes into 57 times. 7 times 7 is 49. 50 minus 49 is 1. Bring down the 0. 7 goes into 10 one time. So it's either 71% or 72%, depending which comes next. So 7 goes into 10. Wait a minute. I'm sorry. 1 times 7 is 7. Bring this down. 10 minus 7 is 3, and we bring down this last 0 to see if it rounds up or stays the same. 7 goes into 30 4 times. So 0.714 is roughly 71%. That 4 is going to make this 1 stay the same. So roughly 70. That's a pretty bad roughly sign. Let me do that again. Roughly, rounded to the nearest 100, it would be 71%. Roughly 71% of the students own a smartphone. All right, Eli's Electrics. Let's see. Eli's Electronics has a 60-inch television on sale this week for $798. This television is regularly priced for $1,050. What percent did the price of the television decrease? Okay, so percent of change is going to be amount of change. Let me change to a different color here. Amount of change. How much it's changing over the original amount. So, amount. That's our percent of change. How much is it changing over the original amount? Well, our original amount regularly priced for $1,050. So, how much is it changing? Well, let's use a calculator just to speed it up. 1050. 1050. So it's the biggest number minus a bigger number minus a smaller number minus 798. The amount of change. Oops, I messed up there. 1050 minus 798 equals 252. Okay, so we've got 252 is the amount of change. The original amount is $1,050. Okay, now if we were going to do this by hand, we would definitely want to simplify this first. We could divide by 2, but since we have our calculator handy, we would simplify it and then top in, bottom out. Since we have our calculator handy, we can just type it in, and we've got 252 divided by 1050, and that gives us 0.24, 24 hundredths. So we know 24 hundredths. In order to turn a decimal into a percent, we move this guy 2 times to the right. So that's going to be 24%. That's a 24% decrease. 24% off. So if you had a 24% off coupon and that was the original price, that's what you would get it for, $798. Alright, moving on to number 4. Marina's bill for dinner totals $38.65, including tax. She leaves a 20% tip. If she plans to pay with a $100 bill, how much change will Marina receive? Okay, so if we want to find 20% of a number, we turn this to a decimal and multiply. So 0.2 or 0.20 if you want, it's the same thing, times 38.65. Now we multiply these two, we will get $7.73. $7.73 is 20% of $38.65. So we want to know if this is how much she's tipping, that's 20%. We can add that to the 38.65, make sure we line up that decimal, and we get the total that she would have to pay. It would be $46.38. With tip, it's $46.38. But that's not even what they're asking. They're asking how much change will she receive. So she pays with a $100 bill. She pays $46.38. We make sure we line up this decimal, and that gives us the change that she's going to get, which is $53.62 change. So that's our final answer right there. $53.62. Moving on to number 5. Excuse me. During a field trip to a local soda manufacturing plant, students watched as 12 sodas were dispensed in 1.5 or 1.5 minutes. At this rate, how many minutes will it take to dispense 12 dozen sodas? That means 12 times 12 sodas. So we want to make a proportion here. We got 12 sodas. I'm just going to put an S for every 1.5 minutes. I'm just going to put an M. I'm going to be lazy there because I know S is sodas, M is minutes. So I want to know for 12 dozen sodas. That's 12 times 12 sodas. Well, that gives me 144 or 12 dozen sodas. So then I got to do 1.5 times 12. What I do the top, I got to do the bottom. What I do the bottom, I got to do to the top. And that's going to give me 18 minutes. Remember, we don't line these up, we just bring back the decimal. So 18 minutes for 12 dozen or 144 sodas. So now, next question. How many sodas does the factory dispense per hour? Okay, well, an hour is 60 minutes. So let's look at this. We have 12 seconds for every 1.5 minutes. If we do times 10 times 10, we get 120 sodas for every 15 minutes. Remember, when you do times 10, you just move the decimal one time. So 120 sodas for every 15 minutes, and we want to know for 60 minutes. 1 hour is 60 minutes. We just do, well, 15 times 4. 15 minutes is a quarter of an hour, so 15 times 4 is 60. What we do to the bottom, we got to do to the top. 120 times 4 gives me 480 sodas per hour. 120 times 4 is 480. Munson Sports Goods. You know what? We're going to have to save this for the next video because we're running out of time.